For decades, we had a pretty clear picture of the universe's early days, a huge, quiet, and totally dark age that went on for hundreds of millions of years right after the Big Bang. It was a cosmic fog of neutral gas just waiting for the first little spark of light. But what if that whole picture is wrong? What if the universe's dawn wasn't some slow sunrise, but a sudden, brilliant explosion of creation? A Nobel Prize-winning scientist, Dr. John Mather, has been a guiding force for the James Webb Space Telescope since the very beginning. Now, the telescope he helped build is looking back to the edge of time, and its discoveries are forcing us to question everything. These finds of impossibly ancient and massive galaxies aren't just rewriting textbooks, they're challenging the very story of cosmology. So what exactly did Webb see that has everyone so stunned? To get why astronomers are buzzing, we need to go back to the beginning. Our modern story of the cosmos starts with the Big Bang. From an infinitely hot, dense point, everything expanded, and as it grew, it cooled. About 380,000 years later, it was cool enough for protons and electrons to team up and form neutral hydrogen. This moment released a flash of light we can still see today, a faint glow called the cosmic microwave background, or CMB. The man who helped prove this with stunning accuracy was Dr. John C. Mather. His work on the COBE satellite gave us our first detailed baby picture of the universe and won him the 2006 Nobel Prize in Physics. But that picture also set the stage for what came next, the cosmic dark ages. After that first flash of light, the universe was filled with a thick, light-swallowing fog of hydrogen gas. No stars, no galaxies, nothing to break up the gloom. For hundreds of millions of years, the universe was just dark. The standard model of cosmology, our leading theory, suggested that the first stars would eventually ignite, kicking off a slow, gradual process of gathering into small galaxies over a vast amount of time. This was the story almost everyone agreed on, and it's the story the James Webb Space Telescope was built to finally see. The Hubble Space Telescope gave us some incredible views, but it couldn't see far enough back in time. It couldn't peer through the dense dust clouds where new stars are born. So, as John Mather himself said, the moment Hubble started working, the team knew they needed something even more powerful. Enter the James Webb Space Telescope. It's a $10 billion time machine with a massive golden mirror, 21 feet across, designed for one main goal: to see the end of the cosmic dark ages and witness the birth of the very first stars and galaxies. So, how does it do it? With infrared light. As the universe expands, light from the most distant objects gets stretched out on its journey to us. This is called redshift. Light from the first galaxies might have started as visible or UV light, but after traveling for over 13 billion years, it's been stretched into the infrared spectrum. Webb's golden mirror and incredible instruments were specifically designed to catch this faint, ancient red-shifted light. As the senior project scientist for JWST since 1995, Nobel laureate John Mather helped guide this instrument's creation. His Nobel-winning work with COBE had defined the starting line, the cosmic microwave background. Now, Webb was meant to see what happened when the race finally began. But no one, not even the team that built it, was ready for what it found. Almost as soon as it was switched on, Webb started finding them, tiny red dots hiding in the deepest pictures of space ever taken. When scientists analyzed the light from these dots, the results were staggering. These weren't just a few stars, they were whole galaxies, popping into existence much earlier than any model predicted. One of the first record breakers was a galaxy named Jade's GS Z14. The name is a mouthful, but what it means is huge. Analysis confirmed it existed just 290 million years after the Big Bang, an era we thought was almost impossible to see into. But the real shock wasn't just its age, it was its size and brightness. This galaxy was already glowing with the light of hundreds of millions of suns and was over 1,600 light-years across. Brant Robertson, an astronomer who co-led the team that found it, said the discovery was completely unanticipated. And it wasn't the only one. Other teams started finding other shockingly bright and well-developed galaxies in the universe's infancy. Instead of the small, faint baby galaxies they expected, astronomers were finding structures that looked more like cosmic teenagers. Kevin Hainline, a member of the JWST team, put it perfectly. We really shouldn't have found a galaxy like this, given our understanding of the way the universe has evolved. They were even spotting the chemical signature of oxygen, an element that needs to be forged inside stars and takes time to build up. Everything was happening way too big, way too bright, and way too fast.
This is where discovery creates a fascinating new puzzle. The data from Webb is posing a direct challenge to our models of how galaxies form. The standard model of cosmology is built on the idea that structures form slowly. Little things merge to become bigger things over billions of years in a process of slow gravitational accumulation. But Webb's discoveries suggest a different story, one of cosmic sprints, not a marathon. These early galaxies seem to have burst onto the scene almost fully formed. According to our current theories, forming a galaxy as massive as JSCAD's GSZ-14 in under 300 million years is like trying to build a skyscraper in an afternoon. There just shouldn't have been enough time for gravity to pull that much gas, dust, and dark matter together and light it up with stars. So what's going on? That's the question lighting up astronomy departments all over the world. Are our models of galaxy formation wrong? Or are they just missing a key piece? How did the universe build such massive structures in the blink of a cosmic eye? The crystal-clear data from Webb is creating a wonderful tension with established theory, and it's pushing cosmology into exciting new territory. If you find these cosmic puzzles as fascinating as we do, make sure you subscribe and hit that notification bell. We are just getting started on this journey to the beginning of time, and you won't want to miss what happens next. When science runs into a problem like this, it doesn't panic, it gets excited. A puzzle means there's something new to learn. Right now, theorists are scrambling to come up with new ideas to explain Webb's impossible finds. One idea is that the very first generation of stars, known as population 3 stars, were way more extreme than we thought. Theory suggests these stars made of pure hydrogen and helium could have been hundreds of times more massive than our Sun. They would have burned incredibly hot and died in spectacular fashion, and their intense radiation could have blown away the cosmic fog much faster than we expected, jump-starting galaxy formation into high gear. Another even more intriguing idea is gaining ground: primordial black holes. What if the Big Bang didn't just create matter and energy, but also made black holes right from the start? These ancient black holes could have acted as gravitational seeds. Instead of waiting for matter to slowly clump together, galaxies could have formed around these pre-existing anchors, pulling in gas and dust at a ridiculously fast rate. This might explain how both supermassive black holes and huge galaxies showed up so early. In fact, some scientists now think the surprising brightness of these early galaxies might be coming from gas furiously feeding these giant black holes, not just from starlight. These are just a couple of the new theories being debated. We are watching a scientific revolution unfold in real time, where old ideas are being tested and new ones are being born. From the first clear picture of the cosmic microwave background to the stunning revelations of the James Webb Space Telescope, Nobel laureate John C. Mather has had a front-row seat to our changing understanding of the universe. His work has bookended the cosmic dark ages, first by helping prove where they began, and now by being part of the team that unveiled how they ended. The James Webb Space Telescope was built to find the first faint flickers of light after an eternity of darkness, but instead of finding a few lonely candles, it found a bonfire already raging. The discoveries of these impossibly early massive galaxies have complicated our simple story of a slow cosmic dawn. They've forced us to confront what we don't know and to imagine a more dynamic, more dramatic, and more surprising early universe than we ever thought possible. As John Mather has said, this is just the beginning. Webb has unlocked a treasure chest of cosmic secrets, and we've only just started to look inside. The story of our universe is still being written, and for the first time, we have a pen that can write its very first chapter. Thanks for joining us on this journey to the cosmic dawn. If you find these cosmic puzzles as fascinating as we do, be sure to subscribe and share this video with anyone who looks up at the night sky and wonders.